Camila is next, and this gives me an opportunity to talk a little bit about the process of selecting a capstone. So you come to grad school, and you're enrolling in this program that covers a whole lot of stuff, a whole lot of interesting stuff. And you have your own background that you come in with, the things you're interested in, the stuff, tools you know how to use. And then there are topics that kind of just strike you as, wow, this is really interesting. And I remember, every year somebody kind of stands out in terms of like just going through the process with them of deciding what to focus their energies on for a capstone. And we had this activity this summer about lithium extraction and I think at this point in the world, about 70% of the lithium that we extract to use in EV batteries and storage batteries for the grid, et cetera, comes from Bolivia, Argentina, and areas in Chile from the Atacama Desert. And it results in a lot of water being taken. And the net yield of the lithium is pretty low. And to actually get the raw lithium, which is then refined in the global supply chain, it sits out in giant evaporation tubs in the desert. And there are indigenous communities there that have lived there for a long, long, long time. And now because we have this imperative to decarbonize, right, to have a clean grid, we need this lithium. And there really isn't much regulation, especially in Chile, about the methods by which this evaporation occurs and methods to figure out how to remediate the damage that is done to these ecosystems. And we did an activity on that this summer, and Camila was very interested in that topic, and I thought almost for quite a long time that she was going to do a capstone on related to lithium. And then we pivoted, and it was always a definite possibility to pivot to blue carbon. And I'm glad you did, because you had the opportunity to work with the great Dick Norris. I don't know if Dick is here, but longtime Scripps professor, been really heavily involved in MAS programs for a long time. And I think this was probably the right choice, because this is more aligned with background. But I think the point of this is really that we cover a lot of stuff, and your mind, if you're listening as somebody who's going to be in the program, I know we have some people here, your mind will take you in a lot of different directions when you're here. So just learn and keep developing that interest. And if it's not something you ultimately work on for a capstone, that's great. You have something that maybe after you'll keep reading about and keep learning about. So the capstone isn't just something you show up and you're like, oh, I'm going to do this. It's a process we all go through together, figuring out what are we going to do? What are we going to focus on? What are the deliverables going to be? And it comes down to today. But it's a long process, and it's really a credit to Camila and all of these students that within a year they're able to pick these really amazing topics and execute these projects. So, floor is yours.
Thank you for that introduction. Even though I am not talking about lithium, and I was also interested in like geothermal lithium extraction, I still was able to word in I'm going to mention a salt pond or a salt marsh. So that's like similar to no lithium. So lithium's still on my mind. Okay. All right, so hello everyone, welcome. My name is Camila Pauda, and my capstone presentation for today is called Blue Carbon Ecosystems in San Diego, Exploring the Soil and Challenges in Restoring Coastal Wetlands. So the outline for my presentation today, I'm gonna start off by talking about some background information and my motivation for choosing this topic, and then I'll talk about specific aspects of coastal wetland restoration and implementation challenges, sprinkled with some opportunities, and then end with recommendations. So blue carbon is a term for the carbon stored in coastal vegetated marine ecosystems. These ecosystems, such as salt marshes, mangroves, seagrass beds, are called blue carbon ecosystems. And I chose to focus on salt marshes in San Diego for my project. I also refer to them as coastal wetlands. So there has been an increase in interest to study, protect, and restore these areas because they provide many benefits, and their role in climate change mitigation and adaptation is of particular interest. NOAA states that salt marshes remove carbon from the atmosphere at a rate 10 times greater than tropical forests and store 3 to 5 times more carbon per acre than tropical forests as well. And the carbon stored in these wetlands can also be given a value as in carbon credits that can be used in a carbon market. A previous capstone by Patty Clark in the MPC program estimated that the carbon value in Kendall Frost Marsh in Mission Bay can range from $69,000 to $1.6 million, depending on which carbon price is used to calculate the value. And as for adaptation, these ecosystems also help buffer coastal communities from storms and can provide a cool green space for local communities as well. In addition, there's been an increase in policies that are working to incentivize the protection and restoration of these ecosystems. For example, California's climate adaptation strategy has a priority that is to accelerate nature-based climate solutions and strengthen climate resilience of natural systems. And one of the actions under that priority is to protect, restore, and create coastal wetlands. Also in California, AB 2593, called Blue Carbon Projects, was introduced and passed in the Assembly Natural Resources Committee in April 22 and could potentially be signed into law and take effect January 2023. If it were passed into law, it would require future coastal development in California to build or contribute to a blue carbon project such as restoring coastal wetlands. So with all that interest and possible increase in projects like blue carbon projects, wetland restoration projects, I wanted to explore a bit more about what are the challenges in implementing coastal wetland restoration projects here in San Diego. So I focused on the soil and nonprofit organizations that work with managing and restoring these wetlands. So why focus on soil? Well, soil is very important for the wetlands. It's the foundation for a healthy salt marsh ecosystem to function and provide services like carbon sequestration. So then what are some of the characteristics that make up coastal wetland soil? Well, there are many different characteristics, and I'm going to quickly go over 6 of them that I found to be particularly important and interesting. First off, it's a hydric soil, meaning it is formed under conditions of saturation, flooding, or ponding long enough to develop anaerobic conditions. So the water is very important, the hydrology, the way that the water flows in and out of the environment. That contributes to sedimentation and also contributes to an anaerobic condition. And so there's an anaerobic microbiome that dominates the wetland community. So this is important because the anaerobic microbiomes decompose the organic matter and organic carbon at a slower rate than the aerobic organisms. So that also contributes to a higher amount of organic matter that's in the soil. It can, there are estimations where the organic matter can make up 10 to 40% of the wetland soil. That also contributes to a higher carbon stock, or like blue carbon. And then also clay, silt, and sand is important. And in the wetland soils, there's usually a bit more of the fine sediments, so the clay and silt. So those are some of the characteristics that make up a healthy wetland soil. And in my initial conversations and literature search, I learned that poor soil has been used in past restoration projects, or just soil that's not characteristic of marsh soil. And that has led to problems with establishing a healthy, self-sustaining wetland. And part of this is because there are large amounts of soil that's required for these projects. They can range from hundreds of thousands of cubic yards to millions of cubic yards of sediment that's required. And it's difficult to find a lot of fine sediment to use in these marsh soils, or even to reuse marsh soils, since that is the best option. So that led to more soil questions that I investigated or researched in my project. So since a large amount of soil is required, where can you find sources of the sediment here in San Diego? And then since it most likely won't be ideal marsh soil, how can it be amended or improved? And how could it be enhanced, specifically like the carbon stock? So for the soil amendment, I looked into biochar. And biochar is very interesting, and it was a new topic for me. But it's another possible tool for climate mitigation. So it's a type of charcoal that's created by burning waste, such as food waste, yard waste, or sewage sludge, and it's burned in an environment with low to no oxygen, and it results in a type of charcoal that could be called biochar. It typically is used in agricultural soils, and it's been shown that it can improve water retention and also moderate the pH of the soil. So there's more research that needs to be done on biochar's impacts on agricultural soils, and there has been very little research that has been done on biochar's impact on wetland soil. The soil conditions in these wetland soils are very different than agricultural soil, and then also there is a lot of variability when it comes to producing the biochar and the biochar's properties, depending on which feedstock is used to produce it and the amount of time and temperature that the biomass is burned at. However, there is still a lot of potential and interest in using biochar for wetland restoration projects, and I found 2 case studies I decided to focus on, and they're both located here in California, and they both had certain aspects of it that I found to be interesting and wanted to apply here in San Diego's case. So first, there's Hester Marsh, which is located in Elkhorn Slough in the central coast of California. It sourced its sediment from local sources, and that included granite, some local sediment from a Pajaro Valley project, and also from soil from local agricultural fields. They also made their biochar from eucalyptus trees that were also on Elkhorn Slough, and then with that biochar, they put a tablespoon of it in each little planting hole where they transplanted marsh plants. They did not see any positive impacts for the biochar, impacting or helping the plants grow, and it was most likely because or contributed by the small amount of biochar. Because conversations I've had and also literature that I read stated that in order to see any positive impacts from biochar, you need to use a lot of it. And then Magoo Lagoon, located in Ventura County, they used clean fill. They did not state where they got that fill, but they stated that it was fill not characteristic to marsh soil. However, they did use a lot more biochar, and that biochar was actually a mixture of biochar and compost. And they stated that they mixed it from a 1-to-1 ratio for biochar to soil, or even a 2-to-1 ratio. So they used a lot more biochar, and they did see positive impacts on the plant growth and survival rates in the areas that had biochar. So I wanted to apply some of those concepts here to San Diego, specifically with the Hester Marsh case study. They got their sediment from local sources, local areas. So I wanted to see if there was any information out there available for sediment sources here in San Diego. So I did find a report that was for SANDAG on managing sediments here in San Diego. I feel like this table shows the main points that I was looking for, and it shows that there are various sources or locations for sediment, ranging from upland soil to offshore ocean, and there is a variety of grains available, from fine grains to rocks, and there are also a variety of properties or criteria that you need to analyze when determining if you can use these sediments. And then I also found this web tool that is used in the San Francisco Bay Area called Sediment, and what it's used for is to connect the dredging communities with the restoration communities that need sediment. So on the map here, you can see the red circles, and those show areas that need sediment, and then the blue triangles show areas where sediment is stockpiled. So if you're to go on here, you can put in some data or information, it's I need this, and then if there is any sediment available, you get the contact information and can reach out to the people to get the sediment. So I propose that this could be a great tool to use here in San Diego to translate the information on the table to a tool that you can use here. And then in terms of biochars, since Hester Marsh did use their local eucalyptus trees, I wanted to see if there were or how much waste or possible feedstock to make biochar is available here in San Diego. So this is a little graph that I made with using some numbers that I found. So first, looking at organic waste, such as food and trees and other plants or tree trimmings. The yellow shows 400,000 tons of organic waste, and that's taken from the City of San Diego's 2012 Waste Characterization Study. And most of this food waste goes to landfills. And also in my report, I proposed possibly using some of this organic waste to make biochar could also help the city meet the SB 1383 goals, which is requiring cities to reduce the food waste that goes into landfills so that they're not super full, and then also reduce the amount of methane produced. And then for the second, or the other 2 bars, I looked at wastewater or biosolids. The green shows the amount of biosolids produced in the city of San Diego in wet tons. And the city of San Diego reported that they produced about 130,000 wet tons in 2021. And then the orange shows the amount of dry tons of biosolids produced by Encina Wastewater Authority. So they serve Carlsbad, North County area. So for this main purpose was just to see what's out there. Is there any potential possibly to maybe use some of this feedstock or explore to using this feedstock to produce biochar? And I would argue yes, especially with organic waste. And then for the nonprofits part, I had a series of conversations, and I also sent out a survey where I asked participants to indicate which stages of restoration they experienced challenges in, and to provide examples, suggestions for improvement, and best practices. To summarize the main points, best practices include collaboration and partnerships. For example, volunteers was mentioned a lot as being very important with managing and restoring these environments, and as well with connections with other nonprofits, contractors, city, and agencies. For challenges, funding was mentioned and indicated the most times as being the stage where there's a lot of challenges, followed by land access, maintenance, the grant application process, as well as the permitting process. And then I wanted to dive a little bit more into funding and then like costs, so why that's so important. Well, partly because the grant application process is long. Also, the cost for these projects can be very expensive, which was very new to me. For example, the proposed plan for Rewild Mission Bay could cost anywhere between $46 to $98 million. Pond 20, the salt pond, that's owned and operated by Port of San Diego, could cost $35 million possibly for construction costs. So also in these conversations and the survey, carbon credits was brought up a lot as a possibility to offset these costs. So that's why blue carbon is also very, there's a lot of excitement in blue carbon markets. And then also in my report, I proposed possibly biochar could also be used as a carbon credit, especially because for many like large restoration projects, these wetlands that are created or being restored don't have a lot of carbon in it already, especially if you're not using ideal marsh soil, and it takes a while for carbon to add to these wetlands naturally. So maybe biochar could be a way to get carbon in it really quickly, get some carbon credits. Hopefully biochar would also help the plants grow, and then also just add some value to these wetlands. And these numbers down here, $2.5 million to $10 million, as a back of the envelope kind of calculation estimating how much carbon credits Rewild Mission Bay could attain if you were to amend some of the soil with biochar. And then recommendations that were taken from the survey included streamlining the grant applications and permitting process to make them just so easier and more attainable, especially for the smaller nonprofits that don't have a lot of staff to work on these. And also to create a centralized database that could be anything or include anything and everything related to coastal wetlands and blue carbon. And the middle picture is a picture of a map that I created, and right now it's just indicating some of the coastal wetlands here in San Diego. And my idea is that maybe this could be the basis and beginning of this centralized database where you can go on here, click on the coastal wetland, get some information about the nonprofits and other agencies that are involved with managing them, and get information about the wetland. Is it restored? Is it natural? And maybe also get some information about the wetland soil itself. And then to finalize, this is my vision for the future, my recommendations that just taking everything into consideration, all the research I did, the conversations, the survey, I would recommend there be more research on natural and restored wetlands and more research on biochar, especially its impacts on wetland soils. Create a centralized database with blue carbon ecosystem restoration data, promoting collaboration, beneficial reuse of local sediment. Create a biochar market, produce biochar to reduce organic waste and landfill and sequester carbon, and use biochar in wetlands to improve soil, increase plant growth, and add carbon value. So with that, I want to thank my committee members. Thank you very much for your time and for all your help. And thank you also to everyone that I've reached out to, talked to, helped me out. I really appreciate the time you took to help me. And then thank you everyone for listening, and I'll be happy to take any questions.
Great presentation, thank you very much. The process of creating the biochar involves burning, of course, and presumably that releases some CO2 into the atmosphere. Can you speak to perhaps what the overall outcome is if you apply biochar to those places? Like, I know that the idea is to add to a carbon sink and sequester more. But with the balance of creating the biochar in the first place, does it overcome the initial sort of like release into the atmosphere that you do to create that biochar to then sink it into the ground.
Yeah, so like the carbon footprint kind of producing biochar, what is that like? Or would that
Right. How does
balance
it,
out
what does it,
using-
yeah, exactly. How does it, what does it do to the scales?
Mhm. Yeah, good question. So biochar with the production, especially if it's produced in an environment with like no oxygen, it's like smoldering instead of actually combusting. So with combusting, that's what produces CO2. So with this pyrolysis production, I believe no CO2 is produced because there's no oxygen, ideally, in this pyrolysis production. But there are some other byproducts, such as like syngas, and some of the papers that I read argued that you could use and capture that syngas or biogas that's also produced, use that energy to also produce or bring it back to produce more biochar, or even use that energy produced to use it in other systems that need energy. Yeah, so it's a pretty promising production where it wouldn't produce CO2 while producing energy and sequestering carbon.
Amazing project, Camila. So cool. I'm curious, did you come across any municipalities in your research or recycling facilities that were thinking about taking yard waste or municipal waste and trying to integrate them into a biochar like feedstock system? Yeah,
Definitely. I did come across some. It was mostly very small scale. I'm forgetting where, I think in like Pacific Northwest, like somewhere near like Oregon area, there are some smaller nonprofits that go around and collect food waste and then creates biochar with it. And it's mostly like nonprofits that do that. But I did come across this report where Stockholm won the city won a big competition where they are actually producing biochar from the waste that their city produces, and they're using that biochar to put it in the soil for their trees there. And so that won a big competition. And my original idea, like before all this was made, was maybe I could use that as a model for a city of San Diego, but it didn't make it into my report, but it's definitely something that I'll like keep an eye on for the future.